Hello, and welcome to Virtual Science Saturday, part of Hagley from Home. I'm Leanne, and this week's topic is Coding Unplugged. You'll learn about the difference between coding and programming, and at the end your challenge will be to create your own code and program, but the catch is, we won't be using technology. How's that possible? Stick around and find out. It seems that now that technology is part of everything that we do, from our phones to computers, ordering food at a touchscreen, and even our cars are run by computers. So it's important to at least have a basic understanding of how technology works and how computers know to do what we tell them to do. Computer code is the language that computers use to store information and execute programs, whereas the script is the entire set of instructions that form a computer program to be performed by a computer. Computer code is very important. Almost every electronic device you use relies on code. The way things work can seem quite confusing, but when you break it down, it's pretty simple. Computers have their own language called machine code, which tells them what to do. As you can see, it doesn't make a lot of sense to humans. Each number or letter is telling the computer to change something in its memory. This could be a number or word or a little part of a picture or video. Machine code is also known as machine language. It is the elemental or most basic language of computers. It is read by the computer's central processing unit, or CPU, and is composed of digital, binary numbers and looks like a very long sequence of zeros and ones. A language based on only two symbols is called a binary language. Binary code is the most basic language of computers. Bi meaning two, and nary meaning of. So it's a language of two symbols, and in this case, zeros and ones. If we only used a 1 and a 0 by themselves, we would only be able to say two things to the computer, yes or no, on or off. So what we do is we clump the numbers into groups of 8. So by clumping these numbers of zeros and ones into groups of 8, we can say longer and more complex things. For example, the alphabet is made up of clumps of 8 zeros and ones per letter. Let's try writing our names in binary code. Here I have the alphabet and the binary code that goes with each letter. If you'd like, please pause this video at this point and use this screen as a reference. You can also Google this at a later time. Now I'll show you how I wrote my name. So I wrote each letter spaced pretty far apart so that I could fit 8 numbers that goes with each letter. Then I looked at my chart and wrote down the numbers that correspond to each letter underneath. I can't imagine having to write out my name in binary code in school every day at the top of my paper. Here's another way of practicing binary code. This chart has substituted the zeros and ones for blue and white blocks. So I'm looking for my first initial and seeing that it's the same code as the zeros and ones, but now I'm going to use blue and white popsicle sticks. And you can do this with just about any item. At Hagley, one of our favorite activities is to make binary bracelets. We use blue and white beads to represent the zeros and ones. If you have any beads at home, you can give this a try. What types of creative things can you think of to use as symbols for zeros and ones? While binary code is useful for computers to directly access information, it's not very practical for people to be able to use it. It would take forever to write any kind of script or long set of instructions for a computer having to use something like binary code. So what computer engineers do is they use something called a source code. The source code is a higher level programming language, meaning that humans can read it, and it's more complex than what computers can understand, so they will need eventually a translator to be able to access that information. Here on the screen you can see a screenshot of a source code from a web page. It probably looks like a lot of gibberish, but someone who's fluent in that particular language, this is HTML language, would probably be able to understand it. There is another language called Java that is also commonly used for programming. Let's take a look at how to access a web page's source code. It's pretty simple. So here we are on hagley.org, and I'm just looking at all the different options that I have for clicking and the pictures, and it all looks really nice and easy to understand. Let's go into Hagley from Home, and I can see the different options, and let's look for the source code. So I would right click on my mouse and click View Source. And so we'll bring up a different tab, and here you go. This is the source code information, and at the top you can see that it's written in HTML, that's one of the languages, and I scroll down and I can see some links in here actually, and these links are active. I could click on them and another screen with that extension will open. But if I scroll all the way down, it's just a bunch of words. It's not interesting. There's no pictures. Those are embedded into the source code as where the pictures came from, but I can't see them. The computer can read this and translate it into what I see. But just from this code, it's pretty hard to understand. A computer program is a set of instructions that gives a task for a computer to complete. A computer programmer is someone who writes the instructions for a computer to perform a certain task. For example, if I wanted to upload a picture to social media, a computer program has to do that. Everything from which button I press to where it gets the picture from on my computer or on my phone. So someone has to know which steps a computer needs to take in order to make that happen. One of the most important jobs that a programmer has to do is give exact instructions for the computer to do its task. And that's a lot harder to do than you might think. Think about giving instructions to someone in your household about making a peanut butter and jelly sandwich. It seems pretty straightforward, right? A couple pieces of bread, peanut butter, jelly. But if you're not exact in how you tell them how to make that sandwich and they've never made one before, things can turn out a little crazy. In this exact instructions challenge, Josh Darnett and his kids attempt to make a peanut butter sandwich. Josh's kids provide him with the instructions and he makes a peanut butter and jelly sandwich exactly how they tell him to, even if they leave something out or assume information. Programmers also have to be very specific with computers, because if they're not exact, then the computer might not follow the instructions as we intend. Unlike humans, computers cannot assume anything. Before I get too far into explaining your challenge today, let's talk about one more coding language, and that's block coding. Things like Scratch and Python are types of block coding programs. This is one of those high-level programming language that people can understand. The main concept is to direct a robot or another device by using symbols like arrows. So you see here, this is my little friend Botley. This guy has some simple directions: up, left, down, and right. As a programmer, I would have to decide how far does Botley move when we press the up arrow or the forward arrow once. Does he move 3 inches, 3 feet? So that would have to be determined. As a programmer, you have to be exact in how you describe that. So I played around with Botley a little bit, and here was my result, with a little bit of help from my dog, Wednesday. For today's challenge, you will play the role of a programmer or a robot. You will need a minimum of 2 people for this activity, whether that be a sibling or a parent, and one person will be the programmer and the other person will be the robot. It's simple. The programmer will write out a code using arrow symbols to direct the robot around the room. We always want to make sure safety is first, so if there's something in the way that might cause injury, please avoid it or remove it from the space. You can set up your room something like how this classroom was set up, and you can have different roles if you have more than 2 people. Remember, if you have footage of yourself making a code or being a robot, please upload it to either Facebook, Twitter, or Instagram and tag us using hashtag HagleyFromHome and hashtag HagleySciSat. We're excited to see what you come up with. Thank you for joining me for Virtual Science Saturday. For more Hagley from Home content, head on over to our website, www.hagley.org.